So we've solved systems using graphing, using substitution, and also using elimination, but we have to continue with elimination here a little bit because sometimes the equations are not quite as easy as they have been for us in the past. So we're going to focus on this step 2, where we might have to multiply one of our equations by a value in order to get one of our in order to be able to eliminate one of our variables. So we're going to take a look at some examples of how that works. So we have, let me start this over here. If I have this very simple equation, 5 plus 3 equals 8, well, that's a true equation, right? Well, what would happen, or can I just simply multiply everything in that equation by the same value and have that still be a true statement? So if I have, let's say, multiply everything by 2. Well, 5 times 2 is 10. So I'm just taking each term and multiplying by 2. 3 times 2 is 6. And then again on the other side of my equal sign, 8 times 2 is 16. Well, if I take a look at that, 10 plus 6 does indeed equal 16. That's a true statement. So if I do that same thing with any value, if I do that same thing with, say, multiply everything by 5, right? So instead of multiplying by 2, if I multiply everything by a 5 instead, so I'm just going to replace that with 5. And now I have 25 plus 15 equals 8 times 5 is 40. And again, that's still a true statement. So as long as I multiply every term by that same value, I'm still going to have a true statement. And if I think about what that is from the past that we've talked about, that's just the multiplication property of equality, which states that as long as I multiply every term by the same value, that equation remains true. So we're going to take a look at how that applies in our systems of equations. And let's get rid of some of this work here. So in this particular system, if you take a look at this, I'm cheating a little bit because you can see my solution over there. I should come up with a 5, 1 as my ordered pair in the end, or as my solution. But let's take a look at how we got there. Now if I take a look at this, I can't eliminate yet because none of my coefficients match. If I try to subtract, if I try to add, I'm not going to eliminate a variable. So before I can add these equations, I'm going to need to use that multiplication property of equality. So let's take a look at this equation. It's nice that this y doesn't have a coefficient with it, so I'm going to work with this one. If I multiply every term here by 2, let's see what happens. So 2x times 2 is going to be 4x. I'm just going to write right over here. And then I have this y, so y times 2 is 2y. And again, I have to do it on the other side as well, so 9 times 2 is 18. Right? So I just took every term and multiplied it by 2. Well, now, if you take a look at these two equations, I now have variables that match. I have coefficients that match. So now I can go ahead and add. So now I have 3x plus 4x, which is 7x. My 2 y's are eliminated, and I have on the other side a 35. I'm going to finish this off by dividing by 7, and I get x equals 5. So I have half of my solution. All right, let's grab another color. So now I'm going to go back up here. If you remember now, this second part here is just simply substitution. So I'm going to substitute that 5 into one of my equations to solve for y. So I'm going to choose the easier equation. Right? So now I have 2 times x, and x is 5. 2 times 5 minus y equals 9. Right? All right, finish this off. 2 times 5 is 10. 10 minus y equals 9. I want to remember that this is a 1y because that's going to come in handy here in a moment. I'm going to subtract 10 from both sides. If I eliminate that 10, I'm going to end up with negative 1y subtract 10 from the right. 9 minus 10 is negative 1. Finish this by dividing by negative 1. And I get y equals 1. So my ordered pair, that last step, is to write this in an ordered pair. X is 5 and y is 1. And if we remember from the beginning, that is indeed our solution. Now I would want you to go back and check that solution by substituting into your system, but we're not going to do that this time. All right, and here's another one that's a lot like that. So if I take this bottom equation and multiply by 2 again, I'm just going to write right over here. Well, what if I, instead of multiplying by 2, I multiply by negative 2? Because that's going to allow me to add. So I'm going to actually multiply by negative 2. Now I can add 2 and negative 2 and eliminate that variable. All right, so I'm going to multiply everything by negative 2. So this actually becomes, let's rewrite this. Let's rewrite this equation down over here. So now I have, if I multiply everything by by negative 2, I'm going to end up with negative 2x. Okay. Positive 5 times negative 2 is negative 10y. And 19 times negative 2 is negative 38. So I've multiplied everything by negative 2. We'll rewrite that first equation up here as well. 2x minus 3y equals negative 1. Now, because I have a 2 and a negative 2 for my x term, I can go ahead and add, which is going to eliminate this piece. And I have negative 3y and negative 10y, giving me negative 13y. Remember, I'm adding a negative 3 and a negative 10. And again, I'm adding negative 1 and negative 38 to give me negative 39. Finish that off by dividing by negative 13. And I'm going to get y equals, again, feel free to use your calculator on these. This one is going to be y equals 3. Equation here and substitute that y equals 3. And I'm going to get x plus 5 times 3 is 15 equals 19. Finish that, subtracting 15 from both sides. And I get x equals 4. So again, last step, as my ordered pair, my solution, or my point of intersection on a graph, is going to be 4, 3. I would want you to go back and check that by substituting, but I'm going to go ahead and just do this, and it looks like we're right. Now, I want to do just at least one more example because sometimes you're actually going to have to multiply both equations by a value. So let's remember what the least common multiple is. So when I say LCM, I mean least common multiple. So if I look at these pairs of numbers, I think about what's the least common multiple of 2 and 5? Well, a really easy way to do that is just to find a multiple at all, I can just multiply 2 and 5, and that does happen to be my least common multiple. Okay, well, what about 4 and 6? If I multiply those, I'd get 24, but there's another multiple of both 4 and 6 that's lower than that. So when I say least common multiple, that's the one I'm looking for. Well, 4 times 3 is 12, and 6 times 2 is 12, so the least common multiple is 12, right? Pause for a minute and see if you can come up with the least common multiple for these last 3 pairs. The least common multiple for 8 and 10, let's think of our multiples of 8. 8 times 1, 8 times 2 is 16. That's not a multiple of 10. 8 times 3 is 24. Nope. 8 times 4, 32. That doesn't work. 8 times 5 is 40. 40 is also a multiple of 10. So my least common multiple is 40. 2 and 3, I can just multiply together to get a least common multiple of 6. And again, 4 and 7, if I multiply those together, I get my least common multiple of 28. Now, what is the point of this? Well, if we have I multiply, let's say, my top equation by 2. I'd have 4x, 8y, and 12. I still can't eliminate anything. I need my variables, or at least one of my variable terms, to match the other, right? So in this case, if I want to multiply, if I want to eliminate my x values, if I want to eliminate this variable, I'm going to have to multiply both equations. Right, so I want to eliminate that by getting both of these to be 6. My least common multiple of 2 and 3 is 6. So how do I get 2x to equal 6x? I'm going to multiply that by 3. How do I get negative 3x to equal negative 6x? I'm going to multiply that by 2. So in this case, I actually have to multiply both equations by something in order to get a variable term to match. So what happens now that I have multiplied? Well, let's rewrite these. So now I have 6x. I'm going to multiply everything in this equation by 3. So 6x plus 12y equals 18. Make sure you multiply both sides of the equal sign. In my bottom equation, I have negative 6x plus 14y equals 17 times 2 is going to give me 34. Now I can eliminate because I have a 6 and a negative 6. So if I add those, I'm going to eliminate this first term. I have 12 plus 14, which is 26. Y, 18 plus 34 is going to be 52. Finish by dividing by 26. And I have y equals 2. All right? So I'm going to go back. I'm going to take that y equals 2 and substitute to find my x value. So I'm going to substitute that 2 right here. Bring that over here. I have 2x. Y is 2. 4 times 2 is 8 equals 6. I'm going to simplify that. If I subtract 8 from both sides, I'm going to get 2x equals negative 2. I'm going to divide by 2. And I'm going to get x equals negative 1. Now I have both values. Write those as an ordered pair. And I have negative 1, comma 2 as my point of intersection or my solution to this system. So I'm going to check that up here. Looks like we were right. Right now in this case, if I had wanted to eliminate my y values, what would I have multiplied by? I would have multiplied by 3 and 2 to get my y values to match. My least common multiple of 4 and 7 is 28. How do I get 4 to equal 28? I would have had to multiply that equation by 7. And again down here, how do I get 7 to equal 28? I would have had to multiply that, in this case, by negative 4 so that I had a positive and a negative 28y down here. Then I can eliminate those terms. So I can eliminate either the x or the y by multiplying. All right, let's take a look at this one. I want you to pause for a moment and I want you to think of what you're going to do in order to eliminate, let's say, the x term in this particular system of equations. So if I want to get the x values to match, right, one to be positive and one to be negative, what am I going to multiply each of these equations by? So again, pause, write that top equation after you multiply it by whatever value you think is right, and then unpause and see if it matches mine. So I multiplied this top equation by a positive 2. So if I multiply every term by 2, I get negative 10x, I get 8y, and I get negative 24. Again, pause and think about now what are you going to multiply this bottom equation by in order to be able to eliminate the x terms. If this is a negative 10x, I want this bottom equation to have a positive 10x. So I'm going to multiply that bottom equation by 5. 2 times 5 is 10, 3 times 5 is 15, and 9 times 5 is 45. Now that I've done that, I can go ahead and eliminate. Because I have a negative 10 and a positive 10, those are gone. I have 8y. Feel free to use your calculator. It's going to give me a negative 7y. And I have a negative 24 plus 45, or I could just say 45 minus 24, which is going to give me positive 21. Divide both sides by negative 7, and I get y equals negative 3. Finish now by substituting to find x. So I'm going to go ahead and replace y here with negative 3, and I get 2x. Now that's going to be minus 3 times negative 3, so minus negative 9 equals 9. So let's simplify this a little bit. 2x minus negative is just plus. 2x plus 9 equals 9. I'm going to subtract 9, balance this out, and I get 2x equals 0. I divide by 2. Well, 0 divided by, right? So my ordered pair here, x is 0 and y is negative 3. So I would go back up to these equations. I would substitute 0 for x, negative 3 for y, and I want to make sure that that works in both equations. So in this top one, 5 times 0 is 0. 4 times negative 3 is negative 12. So negative 12 equals negative 12. And check for that one. Let's try this one. 2 times 0 is 0. Minus 3 times negative 3. So minus negative 9 is the same as positive 9. And that one's going to work as well. So our solution is good. Right? So we could go through a bunch more equations, but here's, again, if we go back to the beginning here, some of the things I want you, or the main thing really I want you to remember is this. Sometimes if the variables don't match and you can't eliminate right away, you're just going to multiply one or both of the equations by a value in order to get those variables to match and then be able to eliminate.